All right. So I think we have a good crowd today, and so very excited to have Bartosz Lipinski, who's a senior software engineer at Solana, over with us today. And this is the first workshop, in a sense, for the Building Out Loud hackathon. And so Bartosz is here to cover everything about how to get started on building at Solana, and he has a wide range of experience in various fields. So he is the guy to answer about everything Solana. We'll have a Q&A also in the end. And yeah, with that, I'd like to invite Bartosz to take over.
Oh, awesome. Thanks for having me here. So brief intro, I started at Solana about 11 months ago now. And I primarily focus on product side of engineering, so building different protocols, different protocols and platforms, things like that, ranging from Rust to React, effectively full product development. So something very similar that you would experience during the hackathon, like how quickly can you go from 0 to 1. So I kind of focus on that during the workshop. What do you need? The workshop is targeted for people that didn't necessarily read the documentation, don't know anything potentially about Solana. So if you know a lot, just bear with me. But I think the good place to start usually is the docs at solana.com. So I will be pasting the links in the Zoom for everyone. So in here, there's a bunch of things. Wish this was structured a bit better, but when you start viewing this, there's I would usually actually start with reading about the accounts. So the account model is something that's kind of different if you're coming from Ethereum or potentially other blockchains. So the main reason for that, Solana has this strict separation between code and data. So your code is what executes the transactions on the blockchain, and this is how you build smart contracts. They are called on Solana programs. And all the data that you want to store is actually stored outside of your program. It's in these accounts. The code itself is stored in an account as well. So when you are migrating, for example, Solidity from Ethereum to Solana, it's introducing a bunch of challenges because in Solidity, you can think of, you can effectively have a single script, and it's almost like a Python or Node.js file where the data is really stored almost with your contract. At least it looks like when you are programming it. On Solana, you need to explicitly think where you are going to store the data. So it's really like going back to university, where you're thinking, okay, what do I store in the database? What's in and how do I read the data? How should I design the diagrams? And then how do I interact it when I'm executing? And when you are thinking in terms of how do I build something, this is actually where I usually like to start, almost with a database diagram of the accounts that will be stored on the blockchain. And it's thinking from the perspective, the blockchain is a database. It's a distributed database with a lot of fancy words, but ultimately it's a database for you. And the smart contracts that are running are just programs that are executed on the database. So ultimately, the starting with the data diagram is where you will have probably the easiest time thinking about what my program is going to do. And then the other reason the programs or thinking of it as a database is making things simpler is you realize the database on its own doesn't do anything. When you store the data in a SQL server, it's not going to change data. You always need to kind of poke it to issue a transaction. And the blockchain is exactly the same. You cannot just say, hey, change something for me. Solana doesn't have a built-in scheduling or eventing system. So any transaction that's actually executed needs to be initiated by someone from the outside. Okay, so accounts now. So the account model is something that we are calling rent. So it allows you to use the native currency of Solana, which is called SOL, and take it and basically pay for storage. And the payment for storage is what we are calling rent. If you preload the accounts with minimum, like there's this thing called, like we are calling minimum rent exempt amount of value that you store in the account, and it's 2 years worth of rent, then you will never be charged. It's fairly straightforward to do from the JavaScript. So if we go to like one of the programs that I have, you can actually query it somewhere in the connection object. Okay, go here. There's this JSON RPC. So whenever you want to communicate with the blockchain from JavaScript, you can use JSON RPC. It's described here as well. Those are all the methods that are available to you. And there's this method that you can call get minimum balance for rent exempt. So you call that, you pass it number of bytes that you want to store in the account, and that returns how much SOL you need for it not to be charged ever. So that's one of the very common patterns when you are storing user data. You basically want to say, hey, I don't want to ever lose that data. So users should pay for the amount of storage that will ensure that it will be there forever. But another one with the account and this rent exempt that you can think of is switching, like thinking of it as a garbage collection, because the rent exemption is, or the rent is charged at a fixed intervals. You can store enough rent to be to have the data available for a fixed amount of time. And you could potentially, like if you drain the account from the SOL that it has, the account will disappear in the same transaction. It will be cleaned away. Yeah, I will cover all the like example projects. Probably towards the end, I will post the links when I'm talking. I will go through a bunch of examples that are available out there. So then the data itself, there's a number of ways you create it. But another one that's also interesting in terms of accounts, even though we are calling everything an account, there's really like 2 types of accounts that are on the high level that are identified by the public key. So public key is the address of the account that you can query from the blockchain. And there's the normal account. Let's say it has the public key and the private key. And there is this thing that we are calling program derived address. It's associated with the account that doesn't effectively have the private key. And the way it works is you can store the data in those accounts from within your smart contracts or programs. And the program then has the ability to sign the transactions for those programs without you having the private key, because otherwise you would be like sitting there and it's like, okay, I have a bunch of data that I want to store. The data is not owned by the user, but the smart contract itself. How can I sign the instructions to modify the data within those accounts? And this is what program derived address is. So you can use this create program address or find program address method, both on the Rust side and the JavaScript side. It will generate an address that you can then allocate memory against, use the rent for those accounts, and kind of take it from there. You can move around the ownership of the accounts. If you want to see a bunch of patterns, how to allocate, for example, accounts, the place that's good to start is the Solana program library. So this is a repository. You can think of it as similar to OpenZeppelin on Ethereum that stores a bunch of programs that are helpful when you're starting. Some of them are deployed, some of them are not. So the one that's showing you how to like allocate accounts in an interesting way is this associated token account. So program ID is basically a program address. Yes, that's correct. So sometimes you see, so that's something straightforward. Let's go to like a token program. I have source here. Where do we start? Here. So sometimes you see something like that where there's a declared ID, and this account has this like prefix here, and you can like, how do I get it? Yeah, fair enough. Sorry about that. All right. So sometimes in programs, people declare it like that. This is actually kind of disconnected, potentially what's on the blockchain. So you need to make sure when you're deploying, you actually have this address. So this one has this nice name. And to create something like that for your programs, you can go to a terminal. Let me try to zoom it a bit. Right. So you can do this Solana keygen. This allows you to generate a nice address. Let's say there's this command grind, and it starts with and I think you generate like something like that, if I remember correctly. Almost there. Okay. So this will search for the public key that starts with XYZ, and it will find only like one of them. This scans the like key space effectively. So it may take a bit of time. The longer the prefix is, the longer it will take. It generated this JSON file now that I can use as my program address. When I'm deploying, I can reference it in the Solana SDK. Right, so this allows you to pass a keeper, and that's the JSON format is effectively the keeper that I generated. You can send a bunch of SOL to that address and start deploying from it, and this will be the address of the program that that you created. So this is how all those were created. Sure. So in terms of the tokens, this may be a good good time to switch from the accounts. So when you have all these accounts, again, think of them as tables. I like also often to think of them as a predefined API for programs to interact with each other. So if you want to read someone's data, you need to understand how they're storing it. And the tables effectively are like the accounts are similar to that. So if you go to the token program, that's the program that allows you to deploy your own tokens. It has similar interface to ERC20, but the main difference is ERC20 on Ethereum is an interface. So whenever you want to deploy the token, you actually need to deploy a new smart contract. You need to write a bit of Solidity. Maybe you copy that Solidity from OpenZeppelin, but ultimately you are the owner of that code. And if there is an issue in it, you need to fix it, or your users may be at risk. Token program is slightly different. So the token program has been created by Solana. It has been deployed on Solana blockchain already, and it's immutable. So you actually don't, if you want to create your own token, you actually don't need to deploy a new Rust program on Solana blockchain. You can just use this one. But in order to achieve that, we have this code that executes the information, how to do token transfers and all, but we need to store some data. So some data for the token program is a mint, and it's also a token account. So the mint defines, again, if you think of it as tables, mint has a bunch of columns. The primary column that you are probably interested there is what's the supply of this mint and who is the owner and if they can mint more tokens or not. So very simple table. And then there's another table, it's called token account, that stores effectively information of the holders of the tokens. And it says, this is the owner of this amount of the tokens for that mint. Yes, not necessarily. Those are not program-derived addresses. So the token account that user holds is not a program-derived address most of the time. And like the mint is not program-derived address. So it created all of them, but it doesn't like change them randomly. And again, the program itself, the token program, is immutable, so it doesn't change. Sure. So I will go back, I guess, back to the program-derived addresses. So program-derived addresses are just public keys on Solana blockchain that are that don't have the private key, and any given program can can execute instructions and sign them for the program-derived addresses that it owns. So the good example would be, let's imagine I have the escrow program, and in the escrow program, I store some additional information in the account that's called escrow account. And that escrow account maybe stores information is like, when was the escrow account opened, and a bunch of other ones. And when I want to modify it, I actually need to sign the transaction with the private key of the owner, but that escrow account is probably owned by my escrow program. So in order to sign this, I would need to store the private key somewhere. But you cannot store it on the blockchain because then it will be public. So we have this program-derived addresses that allow you to sign the instructions to modify the accounts without having a private key. And the only entity that can do that on Solana blockchain is a program, and it can only do that for program-derived addresses that it owns. Right, so hopefully that that kind of answered it. For the languages, most of so technically smart contract platform on Solana is BPF compatible, so you could use any BPF compatible language, assuming you have the SDK. But the ones that we support at Solana is Rust and C++. There is a bunch of projects that build on top of it to support like Solidity. If you look up for the EVM compatible programs on Solana, you'll find it. So answering the question about why do we need to create and close accounts, if you don't need to, like you could imagine there's a program that doesn't create or close any accounts. It would be a very simple program, probably like a Hello World or like ping pong or something. As soon as you want to store some data on the blockchain, someone needs to create the account and pay for storage. That's just a unit of storing something on Solana. So that's one use case for accounts. The other one is if you want to send someone Sol, you need to create an account. But most of the time it's about the data. So interoperability with ERC20. So not sure if I understand the question. For the so you can use Solid, like the answer for the Solidity. You can use Solidity if you use this third-party tools built on top of Solana blockchain that allow you to deploy the Solidity contracts on top of the EVM that's running inside the Solana runtime. Think of it as a ported virtual machine like Java to Windows. It has a bunch of potentially downsides, like Java on Windows is slower. So Solidity on Solana will be slower than writing programs natively in Rust. So if you're like really serious about like building a big product that will scale eventually, I think learning Rust and building things in Rust is a good option. You cannot use Python for building programs on Solana. You will need to use C++ or Rust. So for the ERC20 interoperability, there is this wormhole thing. It's a bridge that was built by Certus1 and Jump Trading. So you can actually see it here. So wormhole allows you to move the tokens between Solana and Ethereum and a bunch of other chains. And it's it's a bridge effectively, but that can be used to move assets. But the new version also supports moving messages across. So it could be like a vote, for example, message by the government on another chain that ends up on Solana. So it would be interesting to see something like that. So step by step. Sure. So let's okay. Instead of like kind of randomly going through this like questions, let's go back to actually like coding something. So if you are starting with a new project, one thing that you can start with is this dApp scaffold. It's not exactly like truffle. It's more like if scaffold on Ethereum. And it will allow you to quickly build the front end and have some base layer for the smart contract. So dApp scaffold. So it's available here. It has both the React part of the application and some program that you have here that you can quickly modify. This is just a hello world, so it doesn't have almost anything in here. It just prints what's your instruction and account. But on the React side of things, it's showing you a bit more. It actually has a context that shows you how to query list of accounts from Solana blockchain and how to interact with them, how to get the token data. So I would like go over this in detail when you are like running it. All right. So going back to the token program, there's a bunch of things that you can do with the token itself when you are creating it. Most of the time people think, okay, I'll just create some coin that represents something and like go with it. But token program itself can be used for many more things. Like I like to think of it as an API and a way to keep internally within your program a ledger of changes. So you can effectively tokenize almost anything. And when you do that, your programs become more composable with other things because now they communicate through this common interface of like tokens instead of understanding your internal data structure that you build that represents, for example, ownership of something. You can use token to represent both the ownership and the quantity of something. So for the front end, okay. So for the back end, it's C++ and Rust. There's frameworks also like Anchor that you can use. This is the one. So this framework is allowing you to interact, like build your programs in a slightly easier way without a lot of boilerplate. It gives you a bunch of solutions to serialization and deserialization, interacting with the JavaScript. So I'd highly recommend it. For the front end, the primary thing that you will need is the Solana library. So there's Solana Web3 JS. So you can just install that, and you can start interacting with the blockchain. And that doesn't need to only happen from the front end. If you're building a simple backend that's reading the data, and you're using like Node.js, you would use that as well. The same API are exposed in the Rust SDK, so you can build a backend in Rust as well. Not the smart contract, but let's say you want to build like a caching layer for some of your transactions. Maybe you will do it in Rust. Right, let me just catch up a bunch of questions here. Yeah, so token program can be used by other programs itself, and they can own the accounts. So this is where the program derived addresses come into play. where you can create a program-derived address for a token account that the program stores. So let's imagine you wanted to create an AMM on Solana. One is actually implemented here as a token swap. So you can take a look. If you're looking how to like interact with AMM, you can look at this. But in the AMM case, let's say you have 2 token accounts for a given pool. You would create them as program-derived addresses, and this is where users would store the liquidity for later to be swapped, and program would sign those transactions. Okay. Sure. So I can go like into some details of the token program. Probably not everything, but I can cover most of it. So everything usually, at least into Solana program library, starts with the processor file that defines list of instructions. All the unpack commands, this is just like how to deserialize data. So this specific one will like just read SPL token account and put it in a format that you can actually understand. Yes, let me finish this token swap, and then I can talk about like NFT and how to create them as well. Okay. And this has a bunch of instructions that are just copied from the token program itself. This is showing you like how to invoke like effectively a CPI into a token program. So this will call the token program to issue a token burn instruction or mint. So if you want to mint new tokens, so the token swap is usually a good place to start, because I think it's fairly straightforward to understand what's happening, and will let you visualize what are the different commands that you need to do, especially if you're interacting with the token itself, because when you commit the liquidity to the AMM, it stores the tokens in the individual accounts, but it also mints new token for the liquidity provider to represent that. And this is how this method is used. It does a bunch of transfers and stuff like that. One thing that you will see in most of the programs on Solana is there's a lot of checks. So those are just like if statements that ensure that everything that you received from the outside is what you expect, and it's owned by people that shouldn't be owned. So it's very important from the security perspective that you, for example, check like, hey, I got this account that is representing a token swap account. It should be owned by me, because someone could create the same, like similarly looking account, just pass it to you and try to trick you to modify it. Same with like token accounts. Like one vector of attack that someone could do potentially is take the token program, deploy their own token program, and modify how the transfers, for example, work, so that the transfers go to someone else, and then try to trick you to use those accounts. So you actually want to check, hey, are those accounts owned by the token program, like this. So moving away from the checks, you will see a bunch of process initialized or process instructions that effectively allow you to have a bunch of different methods against your program. One way to think about those programs in Solana, it's really just like a command line, and you have a bunch of commands that you are executing. So the initialize instruction is just creating a new AMM pool with the tokens. So it has a token A, token B to represent both the accounts, and like a bunch of fees and pools. Yeah, I don't. So for the M1, I'm not using M1 myself. So I've heard people had issues, but I haven't tried setting up anything on M1 myself. So going maybe to like public Solana Discord and asking that question is better. Sorry about that. So high level architecture to what? All right, let me finish going through this, and then I will try to address other questions. But basically the initialization process, you will have something similar in most of your programs where you set up all the accounts that you need. And then you have this, like after all this validation is done, usually the actual code of the program is fairly straightforward. So this like, okay, someone provided liquidity, mint the tokens to them, store all the information in the account that they created, and save it as binary in this specific account info, and then return okay. And like that's pretty much similar structure that you would see in most of the programs on Solana, where first I'm reading all the accounts from this accounts array. Then I'm doing a bunch of checks on those accounts if everything is right. Then I unpack the information to actually read it. And then the actual code itself usually is like very small. Like in this case, this is like just, I don't know, like maybe half of the method or even less is the actual code for the execution. Rest is like a boilerplate around it. Like make sure everything is right, do all the checks, unpack everything. And this is where Anchor comes into play. Like Anchor kind of like avoids having so much boilerplate around the methods. It does a lot of things for you automatically. I don't know if there's much value in going like after each single method, but there's like a bunch of instructions that you will have in this processor file. The other thing that you will usually have is the list of instructions. So those are, at least for Solana programs, those are usually defined as an enum, and they tell you this is the initialize instruction, what it's doing, and there's a bunch of comments that provide information about like what accounts it's taking. So for the C++, let's see, there is a bunch of C++ examples built by the PIF network. So if you actually look into this might be a good place. So this is, there is a program in here that I think is built in C. It's a very simple one. There is also a client. There is a client that interacts with Solana blockchain from C++. So if you're writing a bot or something, you can use this. And there's like a bunch of libraries here. So this is most of it is C++. So is there a way to read into already deployed program on chain? Like how can we look into the code first? So right now there is a way, but it's not necessarily easy. Sorry. Like most of the programs are combined to this BPF, so you need to decompile them to actually read it and have some form of disassembler that converts it to code. So the answer is no, but again, Anchor is allowing you for programs to publish IDL on chain. That makes it a bit easier to read. So Graph Protocol is building on Solana. There is a bunch of projects that are providing indexing capabilities, and you could look into them. But for the hackathon, probably you will not need that. If you want to keep things simple, like Json RPC that Solana provides out of the box gives you a lot of options how to access your accounts easily from Solana blockchain. No, so Solana for IDEs, there is no specific IDE for Solana. The mentality that we are taking at Solana in terms of the dev tooling is really just use what people know. So for Rust side of things, everything is just like plain Rust. You just use and Solana SDK. So you install Solana SDK, which is described actually in like towards this command line. So you go to the like install Solana tool. So this is probably where I should have started with. You go here, you install Solana SDK. And that gives you the ability to compile the programs and everything, interact with the blockchain as well, if you're building some tools around that. And it's fairly straightforward. And that's the only custom tool that you will need to install. Everything else is like either plain JavaScript or plain Rust, where you just call cargo or npm to build your programs or website. Right. So okay, let me catch up, I guess, on the questions.
Yeah, so Bartosz, you can take a look at the Q&A section, right?
Oh,
there's a Q&A section also.
Oh, I was just reading like a normal chat.
Yeah. So, but it's easier to keep track of the questions using Q&A, so you can look at them there. And,
Right. All right, fair enough. I will switch to the Q&A thing. Okay, so let's address the NFTs, since I remember there was a question about that. So NFT standard of Solana has been developed by this thing called Metaplex. And there's a guide around the Metaplex architecture that you can read here. It explains how to create NFTs. Basically, there is a dedicated program for the NFTs. And there's like two things, okay. So there is this token metadata. It allows you to attach metadata to the token itself. So you go to, okay, so you can, at the simplest case, like let's say you want to create just non-fungible token, you can do it like this, right? You call the SPL token create token decimal 0, that creates a new mint that in the token program, and then account where it can be stored once you mint. That's not necessarily just the NFT that you would imagine. Normally, when you create an NFT, you also think in terms of like there's some JPEG or there's some video associated with it. And this is where the Metaplex comes into play, where you can, where with the token metadata, you can take the normal mint and attach a bunch of things into it, like a URI and a name and the description, and then see them in the wallets that support NFTs on Solana. So like this, right? They will like show us pictures effectively. So this is Phantom Wallet, and you can like click on a specific ape and view its attributes. And all of that is stored on the token metadata. The URI in those cases is stored on Arweave. It's exactly the same as the ERC1155. So eventually you will be able to move them through the wormhole bridge, and they will have the same metadata that's out there. In terms of specifically how to create an NFT, the easiest way to go about it is to use this just one file that's a good example here. It creates everything, like it uploads an image and stores a bunch of information there. So take a look at this file and you will be able to create an NFT. Oh, sorry, I'm going too fast. We can create multiple ones, I guess, if you feel like I missed a bunch of things that I should answer. Okay, so sure. So I can talk about the storage. So there's no explicit garbage collection for the accounts that are rent free. Otherwise, the validator processes the list of the accounts and tries to charge them if they have below the rent exempt, and then the accounts are like in memory for the validator. If the account reaches 0, it's cleaned up. So that's like the garbage collection. That's pretty much it. There's not much more to it. I don't know if that necessarily answers the question, but for the padding, since accounts are not resizable on Solana right now, I like to actually attach a bunch of padding at the end when the account is created. So in the future versions, you don't need to do account migration and you don't need to create new accounts. It doesn't need to be a lot, like maybe 100, maybe 200 bytes. Depends kind of on the use case, but add extra things in front of it to be safe. The other one, from the upgradability perspective, it's good to add a version in front of the account if you are not using Anchor, so you can actually like recognize that different accounts mean different things. So I think this one was done already. I think I answered this one. Let me just like clean up a bunch of questions. It's like a lot. So in terms of communicating with Solana blockchain, you use this library that I posted before, Solana Web3.js, and it allows you to interact with the JSON RPC endpoints that we have. Allows you to read transactions, listen to transactions over WebSocket, and submit new transactions that are signed by the user. So take a look at the dApp scaffold. That's a good example for like totally empty thing. But the more complex projects, you could easily take a look at the Metaplex. That does a lot. It has both the program and the like JavaScript client in React that you can modify potentially, especially if you are trying to build an NFT store or something. All right, so the associated token account is, I think, really important, which I didn't cover. So whenever your front end is interacting with account, you should be using associated token accounts for the benefit of the user. So the way associated token account works, it ensures that for a given user, there is only one account of a type for a mint. So let's say I have the USDC, associated token account associates that account for that user for this mint. So the user doesn't have like 20 different USDC accounts, but it has one, and it's kind of easier to communicate with it because people like other apps can then assume that you only have one account of that type, so you don't need to aggregate the tokens across multiple accounts. So hopefully that answers it. Oh yeah, sure. Yeah, I will read the questions out loud. Is the SOL transfer from one account to another account similar to Ethereum? So not exactly. I mean, because you need to use, if you're transferring SOL, you need to call system program.transfer, and it's executed on a different blockchain, I guess. So I mean, it's similar in the sense that it has the amount and like source and the destination, but other than that, not really. Yes. So for every token account, if you want to send, the user needs to have the token account to store it as well. Can a PDF file be used as an NFT? Sure. So I don't think it will display in the wallets, but the way I would do it is read through the Metaplex NFT standard, create a preview of the PDF as an image, and store the additional PDF as a file in the attributes in the JSON like ERC 1155. I think that will work pretty well. All right, looks like okay, so how can we create a generative NFT? Do we need some kind of centralized server which creates a character based on the trades and then mint on chain? So probably you want a mix of on-chain and centralized solution. So I would imagine for the generation of the trades and the images, you want to do that like off-chain, like you want to generate like a PNG files probably. So I would write like some Python script that takes the list of trades, creates some form of distribution of the trades, and then mixes up the attributes. If they were maybe in like a PSD file from Photoshop, then like overlays them on each other and like creates the PNG files. Once you have the list of PNG files and JSON files that are created, like this PNG file has these attributes, I would store them on Arweave, and then you can decide what you want to do. Once you have the PNG and JSON files stored on Arweave, you don't need to necessarily pre-mint everything. You could mint it from a contract. Or you could pre-mint them and then distribute them when users subscribe to something. So for, Eve has a Etherscan for token verification. So on Solana, there's a bunch of explorers. You can use explorer.com to check that token by who was it created and like stuff like that. So the GraphQL question, if I wanted to consolidate data from the Graph protocol, is there a simpler way to use subgraphs for Solana, or would it take a generic approach? So right now, GraphQL is not available on Solana. You would need to roll out something on your own with some form of like custom GraphQL server, unfortunately. So can we use Neon Lab EVM for Hackathon? Sure, go ahead and use it. I think it's a great product. I would love to see more examples of like how people deploy Solidity on Solana, how you migrate projects and what you build. So yeah, I think that's a great idea. Okay, can we use hash maps inside of the Stripe to store data on chain? So this is a good question. I think this is one of the that you hit fairly frequently. The short answer is no, you cannot use hash maps. The longer answer that I think Solana is the hash map, so it's maybe a bit of a like oxymoron, but the way you think about it is the public addresses are keys, and then you can retrieve the data from the hash map by getting the accounts. And if you use program derived addresses, you can actually create predictable hashes if you use like the first nonce that's generated from file program address. So in that way, you can easily store accounts that represents buckets in the hash map or actual values. Right. Can Phantom Wallet interact with Solana dApps? So yes, you can use Phantom Wallet. There's actually a wallet adapter that we are just releasing that contains a bunch of wallets that you can just integrate with. It has a bunch of UIs in Material UI and like undesigned that you can just lift to make general wallet interaction from the React applications easier. Okay, so in terms of collections for NFTs, there is a bunch of options here how you can link them together. If the collection is just like limited editions, there's a dedicated construct in Metaplex metadata standard that's called master edition. So what it allows you to do is take the image and then treat that master edition effectively as a printing rights on the new NFTs, and they will have the edition number. So that's one way you can think of collections. The other way is there are different images. They are fully distinct NFTs, and you just want to group them together on the front end. The way to do it is to add the field for grouping to the JSON format collection, and the front end should be able to group it then. How do we see messages in Solana Explorer? So right now, because some of the information is not available, like stored on chain, you cannot easily see the function names that were called. You need to take the data, deserialize it, and map it to the specific enum that was invoked. So what is the difference between Web3.js and JSON RPC API? So Web3.js provides you a bunch of NPM wrapped functions that call the JSON RPC, and a bunch of implementations like generate a program derived address that's happening on the client side. So they are very tightly coupled together, but you don't need to use Web3.js. Can an NFT transfer from one account to another chain that's linked JSON files? So in general, no, but in long, it depends. The Metaplex standard supports something, both the flag that marks the NFT as immutable, but it also supports something where you transfer the metadata ownership rights. So if something is set mutable and you do something that we are calling full rights transfer, then the user that owns the token is able to modify the metadata. Okay.
Yeah.
Are we done?
Yeah, I think you have answered most of the questions, and
Okay.
like, yeah, I think the rest of them should be able to find answers digging deep into documentation and all. I think this is a great starting point. So thanks Bartos for joining in.
Yeah,
Really
totally. Happy to do another one with more questions.
Yeah, really appreciate you making it. I'm assuming it's pretty early for you.
No, yeah, it's great. I love doing the sessions. So thanks a lot.
Appreciate it.
Good luck, everyone. Super excited about the hackathon. If you have any more questions or you want to discuss your idea, you can always ping me on Twitter. And I try to answer as many as I can.
Sure thing.
All right.
Right.
Thanks a lot.